New information from Tiasak Taluang, Rayong, Thailand reveals a seemingly calm observation that is actually quite unusual. The object appears to have a dense core that stands out against a clean background without any obvious flares or fragmentation. The central brightness remains stable, surrounded by a slight halo. However, upon closer examination, the initial calm begins to look suspicious. The coma, which was expected to be symmetrical, appears to extend slightly to the lower right, a subtle but significant deviation that raises the question of whether there are dynamic processes quietly taking place along that axis. Even in the grayscale image, the asymmetry is evident, as if inviting a deeper dive into the phenomenon. It is from this small but unusual detail that today's update opens up, suggesting that behind the calm may lie a larger story that science is still trying to decipher. When the enhanced color scale viewing mode was applied, the situation changed almost immediately. Details that had previously been barely visible in the grayscale image now appeared with much sharper clarity. The inner coma was no longer glowing uniformly, but was shifted to one side, suggesting that the brightest area was not at the center but seemed to be pushed to one side, while the opposite side was significantly attenuated. This phase shift has been screened for instrumentation errors and image noise, and so far, analysis has pointed to the conclusion that it is the signature of a dynamic process with a directional impact. Matter appears to be escaping the nucleus at a higher velocity along a specific axis, a behavior that is predicted by cometary nuclear models but rarely seen so clearly. Additionally, a faint band has begun to emerge, slightly separated from the central core. This is seen as the seed of a transparent beam, which became more prominent in the later part of the day's data. The consistent presence of this band suggests that 3I Atlas is not simply brightening or dimming, but appears to be restructuring itself. Some observers have suggested that this could be a sign of an active phase transition, heralding an imminent, more powerful jet eruption. Interestingly, this phenomenon occurred at the exact moment the object approached a region where orbital models predicted high uncertainty. While no definitive conclusions have been reached, several independent analysis groups have noted that the deflection of the jet may be creating small but cumulative feedback forces that slightly alter the object's trajectory, a scenario that dynamicists are closely monitoring. From this anomaly, more daring hypotheses have begun to appear on astronomical forums. Some opinions suggest that the restructuring may reflect previous collisions with interstellar matter that we have not yet detected. Others suggest that 3I Atlas may possess a layered structure similar to celestial bodies torn from the chaotic galactic environment, so its response to solar radiation becomes unusual. And as usual, conspiracy theories are not left out. Some people hypothesize that the internal structure of 3I Atlas may contain voids or asymmetric active regions, even considered as natural engineering traces of extreme formation environments that we have not yet fully simulated. While these bold predictions will take time to test, one thing is becoming clear: 3I Atlas is not behaving like a passive blob of dust and ice heated by the sun. It exhibits such consistent characteristics that scientists are asking more questions than they are answering. And that's where the story of this interstellar visitor becomes most intriguing. At this stage in the observation sequence, the high contrast grayscale data began to reveal a clearer signal than initially anticipated. 3I Atlas's core appeared noticeably misaligned, while the surrounding coma no longer maintained the regular circular shape typically seen in passive interstellar objects. The brightness was pulled along a single axis, which matched the direction faintly detected in previous analysis, suggesting a pattern of organized rather than completely random motion. Initial interpretations from observers suggested that this asymmetry reflected preferential ejection, possibly related to local surface activity or the opening of new vents. The dark central region and surrounding halo showed signs of being pulled toward one side, and since the grayscale images capture only the pure intensity without the influence of color data or processing noise, this was interpreted as a true signal from the object. While previously such signals were only suggestive, this observation was seen as direct confirmation that 3I Atlas was ejecting material in a concentrated direction, in stark contrast to conventional dust dispersion models. The anomaly quickly caught the attention of the research community, and many groups began to propose new hypotheses to explain the deflection. Some analysis suggested that deep thermal cavities or cracks could exist inside 3I Atlas as it entered the warmer reaches of the solar system, causing the outgassing forces to become unbalanced. Others suggested that the object might have a stratified core, a structure previously only described in simulations of objects forming in turbulent galactic environments. There are also predictions that the jets from the outgassing may be causing small deviations in 3I Atlas's orbit. While the change isn't large enough to affect its overall path, dynamicists say it could become more pronounced as the object gets closer to the sun. The question now isn't just why matter is projected in one direction, but also is the exhaust regulating the 3I Atlas's ride itself. Even more broadly, some bold hypotheses have been put forward. Some have suggested that 3I Atlas's core structure could belong to a class of objects formed in colliding small galaxies where strong gravitational fluctuations cause matter to be compressed and torn in ways not seen in the solar system. Others have even asked whether yet to be identified factors, such as supervolatile matter or rare compounds found only in the deep interstellar medium, could be influencing how 3I Atlas responds to sunlight. Theories continue to be put forward, but what is clear is that 3I Atlas is not behaving as traditional comet models would expect. The steady deflection of the outflow is forcing researchers to expand their range of explanations, making the interstellar visitor's journey more mysterious and unpredictable with each new observation. Any remaining questions about 3I Atlas's behavior were largely resolved after the new data were processed using the Larsson Sekanina rotating gradient filter. This technique highlights the structure surrounding the object, where a sharp beam pattern dominates the image. The image shows a strong directional beam emanating from the center, while a weaker beam appears on the opposite side. This is a pattern often seen in rapidly rotating cometary nuclei, where material escapes through specific openings rather than being spread evenly throughout the coma. Further analysis reinforced this observation, showing that the beam structure was not the result of image, noise, or processing. The shape of the beam precisely matched the angle of the sun and matched the anisotropic signature that had been observed over many previous frames. The rotational filtering only served to enhance clarity, proving that the signal was present in the raw data as a stable and continuous signal, ruling out the possibility that this was just a transient dust eruption. From these consistent signals, the general consensus is that 3I Atlas is not behaving like a passive interstellar object. The organized ejection behavior suggests that there may be internal mechanisms that are not described by standard interstellar models. This is particularly interesting because objects from outside the solar system are often considered black boxes of astrophysics, with formation conditions that are completely different from those of domestic comets. Several research groups have begun to propose new hypotheses to explain the phenomenon. Some have suggested that 3I Atlas possesses a layered nuclear structure, creating differences in outgassing activity between regions. Some dynamicists have suggested that internal pressure chambers were activated when the object entered a more radiant region of the solar system, causing concentrated jets. In addition, bold hypotheses have also emerged that the object could contain super volatile matter that exists only in a special galactic environment, causing an unusual reaction when exposed to sunlight. In some international astronomical forums, there has even been a suggestion that the jet's remarkable stability could point to incredibly complex internal mechanisms that could stem from chaotic galactic formation or from an evolutionary phase that scientists have never directly observed in a comet. While there is no evidence that this is an artificial phenomenon or an anomaly in the sense of alien intelligence, questions about the object's complexity will certainly continue to be raised, especially as data continue to show that 3I Atlas behaves differently in ways that are hard to ignore. At this point, the only thing that is clear is that 3I Atlas's behavior is defying conventional expectations. Rather than simply drifting through the solar system as a silent visitor, it is leaving behind the imprint of an orderly, coherent, and continuous physical process, a signal that scientists will surely continue to pursue to understand its origins. At this point, the data from the various analysis methods is slowly converging into a more coherent picture of 3I Atlas's behavior. 4 independent processing methods, rough stacking, contrast enhancement, grayscale inversion, and color rotation all highlight details in their own ways, but the end results are surprisingly similar. The agreement between these seemingly disparate methods makes the observed behavior impossible to ignore. In the initial frames, the signal of the light drift appears only as a faint hint, but as the data is increased in sensitivity, the streak of light extending in one direction becomes more obvious. When the grayscale is inverted, the same streak appears with the contrast reversed, and the Larsson Sekanina filter then confirms its existence, revealing a structured light beam projected steadily at a fixed angle. This effect across 4 independent layers of analysis makes the possibility of technical error all but impossible. From these consistent observations, the observers concluded that the signal was not an artificial one. A distinctly directional outflow was present on one side of 3I Atlas, which is rare for an interstellar body, where forces tend to create more symmetrical dispersions. This raised the possibility that the object possessed an organized mechanism, possibly related to a stable active region on the surface or an asymmetric internal structure. Some scientists also noted that the stability of the jet could indicate an uneven rotation axis or even a repeating cycle of activity over time, which the observation teams are continuing to verify over successive nights of observations. The consistency of this phenomenon is exactly what astronomers look for before confirming real physical activity. And since 3I Atlas came from outside the solar system, the unusualness of the signal makes for a more expansive set of hypotheses. Some suggest that the 3I Atlas may have formed in a galactic environment where collisions and strong atmospheric fluctuations create irregular structures from the start. Another, more daring hypothesis suggests that the jet may have slightly affected the object's orbit, creating small but cumulative errors that will soon be tested as the object continues to move deeper into the solar system's gravitational zone. While there are no definitive answers, what is clear is that this discovery raises more questions than it answers. 3I Atlas is showing signs of organized physical behavior that goes beyond the familiar image of a passive mass of dust and ice from interstellar space. It forces scientists to rethink how such objects form, evolve, and most importantly, what else is hidden in these interstellar visitors that we have never seen before. The new data show that the shape of 3I Atlas's jet matches remarkably well with outgassing patterns of objects that form in turbulent galactic environments. The fact that the triangular extension is clearly visible in the color image without enhancement suggests that it may be an intrinsic feature established before the object left its parent system. Preliminary spectral analysis also revealed periodic variations in the intensity of C2 emission at the green core, suggesting that 3I Atlas may be rotating irregularly or possess two competing active regions. This could be a sign of a fragmented core, a structure that is rare in interstellar objects and could explain the stability of the jet. Some groups hypothesize that 3I Atlas suffered collisions during its interstellar journey, creating deep fissures that amplified its outgassing activity as it approached the Sun. Dynamical models suggest that the jet's behavior is consistent with a vertically torn core structure, a type of damage often found in dense galactic regions. Outside the scientific community, more daring predictions have emerged, suggesting that the narrow, stable jet could be the remnants of rare supervolatile matter, or even that 3I Atlas could be the ejected remnants of an ancient galaxy merger. While there is much debate, the consensus is that 3I Atlas's behavior goes far beyond traditional comet models. The natural and consistent appearance of the light in the color images further reinforces the idea that the object is operating on an unusual mechanism, and as it continues to move deeper into the solar system, observers hope that the upcoming changes may reveal more clues about the mysterious interstellar visitor's true origin. While 3I Atlas continues to show sharp, directed jets, JWST data reveal a broader picture of the possible origins of interstellar objects. Images of the slow collision of dwarf galaxies NGC 490 and NGC 485 reveal a turbulent environment of stretched gas and dust, rapid star formation, and gravitationally torn material. Researchers suggest that such turbulent regions may have created icy debris and young cores before they were flung into interstellar space. The directional behavior of 3I Atlas, as evidenced by its steady jet, seems remarkably consistent with that scenario. Some theories suggest that the object may be the remnant of a galactic collision or contain material that only appears in exceptionally young stellar regions. Others suggest that the jet is an inertial remnant from its turbulent formation environment, allowing it to maintain its active orientation even millions of years after leaving its parent galaxy. The coincidence of 3I Atlas's unusual activity with JWST's typical galaxy collision images is striking. The data remind us that interstellar objects often come not from peaceful places, but from regions of the universe where chaos is inevitable. If 3I Atlas looks unusual, it's likely not something worth seeing, but something in the galaxy where it was born. The day's observations show that 3I Atlas was not only brighter, but also elongated along a well-defined axis, revealing a clear, structured jet that pointed in a consistent direction. This directional jet pattern appeared consistent enough over multiple observations to rule out the possibility of it being a one-off phenomenon. When this finding is placed in the context of the interstellar objects that may have originated, namely the chaotic dwarf galaxy environments recently imaged by JWST, the story surrounding 3I Atlas becomes much broader and more intriguing. This raises the question that has been attracting the attention of observers: is the jet stream that 3I Atlas is exhibiting simply part of the natural activity cycle of an interstellar object, or is it exhibiting a mechanism that goes beyond the familiar patterns? On the one hand, this could be a normal response as the object gets closer to the sun's radiation. On the other hand, it cannot be ruled out that these anomalies originate from its internal structure or from the unique environment in which it formed in a distant galaxy, where collisions and turbulence are constant. As data continues to be collected in real time, it is opening up new questions about 3I Atlas and suggesting that the object's behavior may be more complex than current models can explain. If this mutating trend continues, it's likely that future updates will reveal even more surprising details that will reshape our understanding of interstellar visitors. Now, I want to hear your opinion. Do you think this new jet is just the normal behavior of an interstellar traveler, or are we witnessing something that doesn't fit the usual scenario? Leave your thoughts in the comments. I read every single one, and if you follow 3i Atlas daily, like I do, give it a like and subscribe. We're following this in real time, and the next update could be even weirder than today's